Today, I'm going to show you how you can build a full stack automated product tagger application for Shopify using Gadget. The first thing I'm going to do is create my new Gadget app. I'm going to go ahead and select the Shopify app type, click Next, and then enter my app domain. So it'll just be my product tagger demo. Press enter to get started, and this will create a new Gadget app for me. So my Gadget app has a hosted Postgres database, Node.js backend, and React frontend that's powered by Vite. Before I start walking through that stack, I'm going to set up my Shopify connection. So I'm going to click the Connect Shopify button. We always recommend connecting through the partner's dashboard because it allows you to use embedded app front ends, app extensions, and is suitable for both custom and public app development. So really no drawbacks. I'm going to go over to my partner's dashboard. I'm going to click on the Apps tab. Already have done that. And I'll create a new app manually. So I'll just call it my product tagger demo. Now I'm going to copy my client ID and secret back to Gadget and click connect. On this page, I select what Shopify API scopes and models I want to include in my Gadget app. Because I'm going to be reading product descriptions and then writing tags to products, I do need the read and write product tag. Or product scope, sorry. And then I need the Shopify product data model. You can always edit your connection later, so there's no pressure to get it right on the first go. This summary over here gives you a little look at what scopes and models are going to be included, as well as what webhook triggers you're going to get once you press confirm. I'm happy with all of this, so I'm going to go ahead and press confirm. You'll notice that the Shopify product data model has been added to my app, as well as sync, GDPR request, and shop models, which we add automatically every time you connect to Shopify. I'm going to finish up my connection. I'm going to copy my app URL and redirection URL back to my partner's app. Paste in the app URL, do the same for the redirect URL. This is on the app setup page in the partner's dashboard. I'll press save. And then I just need to install my app on a store. So I'll go to the overview tab here. In test your app, I will select a store. I'm going to select one of my development stores, check out branding testing. You notice I haven't written a line of OAuth code. Gadget handles all that for me, so I can install right away. I'm just going to click the install app button. And my app will be installed on my development store here. Fantastic. So my app is now installed. It only took a couple minutes to set up. This is actually an embedded admin app. You can see that this page is powered by ShopPage.jsx. So this is actual React code in your Gadget project. ShopPage.jsx is right here. So that's fantastic. I'm ready to start building my app. I don't have to deal with any of the Shopify boilerplate from here on out. The first thing I want to do is add a data model to be able to store keywords that are entered by merchants. So I'm going to go ahead, add a data model, call it allowedTag. Data models in Gadget are kind of similar to a table in your Postgres database. So you can see that we have fields. Fields are like columns. There's an ID, created at and updated at, automatically generated for you. I'm going to add another field called keyword. It's going to be a string type, which is great. I can always change that. I don't want to though. And I'll add a required validation. So that means if I try and create an allowedTag record without this keyword field, it will fail. So speaking of create, you'll notice that there's a little actions box up here too. So when you create new data models in Gadget, you also get a CRUD API that's automatically generated for you. So I can go ahead and take a look at my create action for my allowedTag model. And you'll see it is a code file. I own this action. I can go ahead and modify this if you want. By default, it's just going to apply incoming parameters and save records to the database. We can go ahead and test this out now. I'm going to click run action. My mutation is already populated, so it is a GraphQL API, so you get GraphQL here. I'm going to go ahead and enter sweater as a keyword and execute this query. And fantastic. We see it was a success. Our allowedTag record is returned here. So it looks like keyword sweater worked. If I go back to Gadget and click on the Data tab, I can see that sweater is now stored in my database. So that's fantastic. So now I have a way to store these keywords. I also have actions for update and delete. I can also test my validation. So I added that required validation. So if I try and create an allowed tag record without the keyword, I get a failure message. It's invalid because keyword is required. So that's fantastic. It's just a good way to test my API. So that's all the data modeling I need to do. I now need to add some custom code to my Shopify product actions. You'll notice looking at my allowed tag actions, the trigger is my app's API. If I go to a Shopify data model, the trigger for the actions are the incoming Shopify webhooks or a data sync. So it's not added to your API by default. The data flow from Shopify to Gadget is one way. So we always recommend writing data to Shopify. That will trigger webhooks to fire, and then Gadget will handle those webhooks so that your Gadget database and Shopify are always in sync. There is a way to call your Shopify API using the internal API. You can check out our docs for that. Okay, so now I want to run some custom code whenever I create or update my Shopify products. So I'm just going to go ahead and paste in a bit of code here. So my run function is unchanged. All that this is doing is going to be saving my incoming Shopify products, that's the record, to the database. On success is where I have added a bunch of code. So what we're doing here is record, that's the incoming Shopify product. We are checking to make sure it has a body, which is the product description. We're using some of Gadget's built-in change detection to see if the body actually changed. So we don't actually need to run our custom code if the description doesn't change. If you're updating pricing or anything like that, we don't need to go through the description again because the tags won't change. All I'm doing is I am getting that record body, my product description. I'm getting a unique set of words in my description. Then I'm using this API parameter, and I'm calling api.allowedTag.findMany. So this is how I read records from my Gadget database. So this will get me my list of stored allowed tag records. And then I am just mapping over those to get just the keywords. So this will be an array of just keywords. Finally, to get my final tags array, I'm just going through my product description or words in my product description and filtering by my allowed tag records. So that's my keywords. And anything left over is what I'm going to apply as tags to my product. So I am using the logger to just write all of this data to the logs. We'll take a look at that a little later. And finally, I am using my connections object to get the current Shopify connection. If it exists, I am going ahead and updating my Shopify product. So the record or product ID is just this record.id, and I'm passing in tags from my final tags object. So this API here, shopify.product.update, that is just provided via the Shopify API node package. So you can see that in your package.json file. Fantastic. So this code will run on create when the create action is fired. I also want to run it whenever one of my product descriptions is updated. So I actually need to share a bit of code here. So I'm going to go ahead and go down to my Shopify product data model. I'm just going to add a new file here at the Shopify product root, call it utils.js, and I'll paste in some code. This code is the exact same that we just walked through. It's just now in a function so that we can import it into my create and update actions. So I'll go to my create action now. And instead of writing all this, I am just going to just copy a little snippet here. We can just call that function and I will import it. From utils. So there we go. So now our create action is doing the same thing. We're just using that utility, and I can do the same thing on update. So we'll just paste it here in my on success. And fantastic. So now that code is going to be run in my update and create actions. I didn't really explain the run and on success function, so I'll just go on a quick tangent here. Run is great for doing database level operations. So for example, if I have a blog post data model and I want to get the word count or calculate the word count before saving to the database, I could do that kind of operation in run. On success is good for side effects or long running operations such as sending an email, sending a text message, or doing anything that's a little more lengthy after the fact. So that's just why we have those two functions there. Okay, I'm going to move on. So that's all the backend code we need. We're now we'll just add the connections parameter here. Very important. Perfect. So now this code will run whenever we create or update our product descriptions. I'm almost ready to hit my front end, but first I'm going to manage my app's API permissions. So if you are building a public app, you also need to handle data tenancy. So you need to make sure that shops can't read or write to another shop's data. I'm going to go ahead and enforce that as well. So this will be like I'm building a public app. If you're just building a custom app, you don't need to go through the steps of enforcing shop tenancy. You still can, but you don't need to. So I'm going to go ahead. I'm going to click on my allowedTag model, and I'm going to add a shop field, and I'm going to make this field a relationship. So that allowedTag belongs to my Shopify shop model. I also have to set up the inverse of the relationship here. So Shopify shop has many allowed tags. We want shops to have many keywords entered. So I'll go ahead and click that. So that sets up my relationship. If I go to my Shopify shop model, you can see that allowed tags is also set here. That's fantastic. Now I need to go do some access control. If I go to settings, roles and permissions or access control, I have this Shopify app users role that will be granted to merchants whenever they're interacting with my app in the embedded admin. I need to grant them access to my allowedTag actions. So I'm just going to select them all. We don't actually need update, but I'm going to select it anyways. I'm also going to add a filter. I'm just going to create a new file called tenancy. And this creates a jelly file. And I am just going to add a little snippet here and then explain what this is doing. So this jelly file is run anytime I read my allowed tags from a client. So this is like from the embedded admin, for example. And it just ensures that the shop ID stored on my allowed tag record is equal to the shop ID of the session. So this just means I can't read someone else's stored allowed tag records. There's one more step I need to take to make sure I can't write to someone else's records. And I am just going to add a function to my create, update, and delete action. So there's this prevent cross-shop data access that I can import from my Gadget server. So I just need to set it up like that. You can see Shopify data models already have it set up here. I'm just going to do the same thing to my allowedTag actions. That's my update. I'll also add it to my delete. One final step I need to take before my app is fully multi-tenant. I need to go to my utils file in my Shopify product folder that has my apply tags function. And I need to modify this line where I am fetching my allowed tag records. So that jelly snippet we applied is only going to be used when I'm making read requests from my API client or through my API client. I'm not doing that here in my backend, so I need to manually apply a filter condition. So it'll just be filter on shop, and I want it to be equals to our current shop ID, which I can grab through the connection. Perfect. So now my app is multi-tenant. It is ready for public app store distribution. People cannot read or write each other's data. So that's great. Let's move on to writing our front end. So as I said before, we have this front end folder. We already kind of talked about shop page JSS. That's what's actually powering our default page. We also get an API client that's been set up for us. This is how we're going to communicate with our Gadget backend. That's all of our actions. There's an about page, which is also part of that default app. And then there's main and app.jsx. So these are kind of your app setup pages. I'm just going to go to shop page and I'm just going to replace what's here with what is in our tutorial. And I will walk through this code now. In fact, let's demo it out first. So perfect. So this is our app front end. Gadget does have HMR, so it does work when you're developing on your front ends, but there is a timeout. So I did have to refresh the page. But if I go ahead and edit, manage keywords, hello, you see that it has updated here on my store. So there is HMR. Let's see if we can actually capture it. There we go. Kind of saw it disappear. So as I said before, we have this API client we're using to read and write our allowedTag data. So you can see that we're calling allowedTag delete and create, and we're using this use action hook to actually help us write data in a Reactful way. We also have a use find many hook we're using to read our allowedTag data. I'm using Polaris for our display. Out of the box Polaris, it'll come installed on your Gadget app. And then use state, that is just normal React use state hooks. I've used callback hooks. It is normal React, so you can write your standard React code as well. This use action hook for our create and delete actions gives me two returned parameters here, or objects. This create tag response, or the response object, has data fetching and error properties, just like down here in our use find many. And then the second parameter is a function that we actually call to trigger this action. So you can see as I highlight create tag, it's called here in this use callback hook. And this is just going to actually save our keyword to my Gadget database. Same thing with delete tag. Delete tag is called in a callback, and this is going to delete the record with this ID. So that will be the allowedTag record. Use find many is how I can read my data. So I'm passing in the api.allowedTag, and this gives us, same as our use action hook, data, fetching, and error. Data is your return data. Fetching is a Boolean, so you can display a loading state. And error is how you can communicate an error to the user. If I go through some of the actual components, you can see we have a form here. That's where we're calling our handle submit, which calls our create tag action. You can see we are using, create tag response error. If there's an error creating a tag, we are just displaying the error to users. You can see create tag response.fetching. So when we're actually in the process of creating that new tag, we're disabling our input box and buttons so that people don't go crazy and click and create a whole bunch of new keywords at once that are all the same. And that's that top section. The bottom section of our existing keywords is just using the tag component, which has an onRemove parameter. And that's where we're calling our delete action, or remove tag, which will delete our tag records. So you do notice if I peek at my front end here, there are no existing keywords. And that is because if I go to my data model, sweater doesn't exist because the shop is null. So because we added that jelly snippet that is filtering on read, because this shop doesn't equal the shop ID of my session, I get nothing. So sweater doesn't exist. So let's go ahead and test this out now. I'm gonna go ahead and add some keywords. We got super, we got duper, hooray. That's fantastic. I can go ahead, let's refresh my data. So I see my tags have been added. They do have the correct shop relationship. I can go ahead and delete my tags, refresh, it's gone. So we know that that is working. That's fantastic. So now the last step is to actually get my Shopify product data into my Gadget database. This will trigger that Shopify product create action and should actually tag my products. So let's go ahead and get started with that. I can go to my connection, click manage connection, and go to shop installs. And then I'm going to manually trigger a data sync. And this will import all of my product data from Shopify into Gadget. So that was successful. I can go look at my Shopify product data. Fantastic. It appears to be all here. I don't have a ton of products in this store. If I scroll over, I see super and duper appear to have been applied as tags. So if I go to my product, now I already know that this product has super and duper as part of the product description. Scroll down and I see that super and duper have been added to this product as tags. I can also check out my logs and I can see that Final tags, here we go. Final tags, super and duper. So I can see that it has been triggered. These tags have been added. That's fantastic. You can also see that some of our other products are also getting tags. So that's why we're seeing multiple events of these logs. It's not just when I actually added the 2 tags to the one product. Fantastic. So that is our full stack product tagger application. If you have any questions, feel free to reach out on our developer Discord or check out the written tutorial. The link will be in the video description. Until next time, I hope you keep building more and coding less with Gadget.